Good morning, Algebra kids. Let's go ahead and let's get started with our second lesson in Chapter 10, which is going to be simplifying radicals. We have a rather lengthy section today, so let's go ahead and let's get started. Hopefully you watched the entire video. Like I mentioned in your notes, you're going to have a surprise problem somewhere in the middle of this that I am taking a grade for. So again, I hope you're paying attention. I hope you're listening, and let's get started. So with this lesson, everything is revolving around radicals. And if you have forgotten what the radical is, all it is that square root symbol. So if I take the number 16 and I draw that symbol around it, well, that's the radical. And I'm asking myself, okay, what times itself is going to give me the number 16? And the answer to that would be 4, because if you do 4 times itself, 4 times 4, you're going to get the number 16. So this is kind of the general idea that we're going to be working with today, working with radicals, numbers that when multiplied by themselves equal that number underneath the radical. So again, this would be read as taking the square root of 16. So our first rule that we have to play with here is when a is greater than or less than 0, so meaning a could be 0, but otherwise it's going to be a positive number, and b is also greater than or equal to 0. So a and b could be 0. With that being said, a times b, we can write this the same as radical a times radical b. And let me show you kind of an example of what that would look like. So if I take, for example, the square root of the number 48, you might be asking yourself, okay, what times itself equals 48? And there's nothing. 48 is not a number where something times itself will give you 48. It's actually the square root of 48 is going to be right smack dab in between if I had 6 squared and 7 squared. And that's because 6 squared is 36, 7 squared is 49. So I have square root of 48, and it doesn't come out to an integer, a whole number. So that's where this lesson comes into play and where we're going to end up breaking these numbers apart. So I'm going to ask myself, okay, what two numbers can I multiply to get 48? Well, two numbers that you can multiply together would be 16 and 3. So because of this rule where a is greater than or equal to 0, and b is greater than or equal to 0, where in this case a would be 16 and b would be 3, well, 16 times 3, I can separate those two and put each of them underneath their own radical. So I have now the square root of 16 times the square root of 3. And that's because these two numbers times each other are going to be equal to 48. It's the same thing, guys, as writing 16 times 3 and then putting that radical symbol over them. All I did was I just broke down 48 into 16 times 3. And that's this step right here. The part where it's equal to, that's going to be equal to this step here. Now I can go through and I can simplify. So the square root of 16, now that does come out to be an integer. That does come out to be a positive whole number. And the square root of 16 is 4. What about the square root of 3? If I were to simplify it, is there anything times itself that equals the square root of 3? The answer would be no, so I'm going to leave that one alone. That's going to still be the square root of 3, and that's because it cannot be simplified. So I'm left now with 4 times the square root of 3. So my final answer, I'm just going to combine those two by taking rid of that multiplication symbol, and it's going to be read 4 times the square root of 3. So this would be my final answer to the square root of 48. Now you might be asking yourself, okay, why did I choose 16 and 3? Why didn't I choose something like 24 and 2 as an example? The reason I chose 16 and 3 is because 16 is a perfect square. And these perfect squares are what we're going to focus on in this lesson today. You want to try to aim for getting two numbers whenever they're being multiplied, and one of them is a perfect square. And if you have forgotten what your perfect squares are, we did review this earlier in the year, but if you have forgotten, the perfect squares would be like 1, 4, 9, 16, 25, and so on. The next one would be 36, and then the next one would be 49. Those perfect squares, guys, that is whenever I'm squaring a number, the answer to that is going to be the perfect square. So 1 squared, 1, 2 squared, 4, 3 squared, 9. So these answers, those results, those are the perfect squares. And notice 16 is a perfect square. So I'm going to write 16 in for this 14, for the square root of 48. So 16 times 3 equals 48. The reason I want these perfect squares is because look at the square root of 16. That's going to be equal to 4. It comes out to a positive whole number. If, say, for example, I had used that previous example of 24 times 2, 24 is not a perfect square, so it's not going to break down into a whole number. And 2 is not a perfect square either. So I'm really not getting anywhere by doing those numbers. So I want to break these down into two numbers when multiplied equal what's under the radical. And hopefully one of them, again, like I said, is a perfect square. So let's look at another example. So let's look at number 1. Number 1, I have the square root of 160. So I'm looking for, if I break 160 apart, what are two numbers that I can multiply to get 160? So maybe you're thinking, okay, if I multiply 2 times 80, okay, are either one of those perfect squares? No. What about if I take 160 and I divide it by 3? Well, that's going to come out to a decimal, so I really don't want to do that. What about 160 divided by, let's say, 4? So if I take 160 divided by 4, I get 40. Well, hey, 4 happens to be a perfect square. So this set of numbers would work. There's more than one way of solving this one, though, however. 160, I'm going to kind of jump ahead here. You could break this one down into also 16 and 10. All of these sets are sets that when multiplied equal 160. These last two guys are both ones that feature a perfect square with 4 in my first set and 16 in my second set. You only need to pick one, but I'm going to show both of them to kind of show you how to get to your final answer. So I'm going to first do the 16 and 10 because this one's going to be the easiest one. If I break this down, it's going to look like the square root of 16 times the square root of 10. Now I can begin to simplify. So the square root of 16 is equal to 4 times, well, the square root of 10. Is the square root of 10 a perfect square? And the answer is no. So I'm going to leave it as the square root of 10. So I'm down now as far as I can go. I've simplified both pieces. So my final answer here is going to be 4 radical 10. Now, as we discovered, we have another set of numbers that also has a perfect square in them, and that is 4 and 40. If I were to have chosen the square root of 4 times the square root of 40, this set of numbers will work as well. What is the square root of 4? Well, the answer to that is going to be 2. So I'm doing 2 times. Well, square root of 40, is that a perfect square? And the answer is no. I cannot just square a number and that answer be 40. Can I break 40 down though? So say I want to break something down in the middle of this. And the answer is yes. I could break 40 down into the square root of 4 times the square root of 10. So now let's go through and let's simplify this set of radicals. So the answer now is going to be 2 times the square root of 4, which is 2, times the square root of 10. And then I'm going to go through and I'm going to simplify my last set. So 2 times 2, here in the bottom, 2 times 2 is 4. So this one's going to be also equal to 4 radical 10. So both times, guys, I got the same answer. I got 4 radical 10. This first set, though, we were a little closer to the answer, just in the simple fact we didn't have as many steps. Whereas in the second time we solved it, notice how 4 and 40 are farther apart than 16 and 10 are. When you pick two numbers that are further apart, chances are you're going to have these additional steps in the middle of solving the problem. When the numbers are closer together, you can kind of get away with doing it just in one step. So kind of see how close you can get to those two numbers being the closest and still having a perfect square. Let's look at another example of one just like these, and then we're going to kind of move ahead because, again, I said we had a lengthy lesson today. I have the square root of 72. Now, 72 is not a perfect square. And guys, I can promise you that almost any number that you're given for your homework, you're not going to get just an easy problem like this where underneath the radical is this perfect square. You're going to have to get an answer very similar to like we got on number 1. So this is not a perfect square, so what can I multiply to make 72? Well, I'm going to kind of jump the gun a little bit on this one, and I know I can multiply 8 times 9 to get 72. So if I do square root of 8 times the square root of 9, are one of those a perfect square? And the answer is yes. 9 happens to be a perfect square. So let's go through and let's simplify this. So square root of 8 times the square root of 9 is what? It is 3. Okay. Now, if you were to write your answer as 3 radical 8, you would not get all the points. This would be partially wrong. And the reason it's wrong is because we can take the square root of 8 and we can simplify that down even further. So what can I divide 8 into? Well, I can divide 8 into the square root of 4 times the square root of 2. And I still want to continue with that 3. Now let's simplify. So square root of 4, that gets broken down into a 2 times square root of 2 cannot go any further. So square root of 2 times 3. And then my final step, I just want to combine like terms. And my like terms here are going to be the 2 and the 3, the whole numbers. So when I multiply those, I'm going to get 6 radical 2. And that is going to be my final answer, 6 radical 2. So always look at, when you're down to these final steps, guys, kind of like how radical 10. Okay, if I split 10 up, I can split that into 5 and 2. Neither of those are perfect squares. Remember over here, we got down to 40. If I split 40 up, I do get a perfect square in 4. Same thing with 8. When I'm down to a radical, the radical 8, that can be broken into a 4 as well, and 4 is a perfect square. So you're always looking to simplify and to break these down into a number that would be a perfect square. And remember, those numbers 1, 4, 9, 16, 25, 36, 49, and they go on and so forth. The one that you're really not going to work with too much is 1, and that's because I could break all of these down forever and just keep multiplying them by 1. So really 4 is going to probably be the smallest radical that you're really going to work with. Let's go ahead and let's look at some problems that feature some variables in them. So let's look at number 3. I have the square root of 54 times n to the 7th power. When we solve one like this, we're going to continue to do the same thing with the number that's underneath the radical. And the number underneath the radical is 54. So I want to break this into two multiples that equal 54, or excuse me, two factors that equal 54, and one of those happens to be a perfect square. So I'm going to break this down into 9 times radical 6. Now let's talk about the variable. Whenever we break the variable down, whichever number is your perfect square, that number, which happens to be my 9, is going to be that variable really just minus 1. So this one's going to turn into 9 times n to the 6th. And my 6th, because that's not a perfect square, I'm going to leave my last variable with it. So my variables, I would add those together to make what I have in my original problem. So 6 plus 1, that's how I got my n to the 7th. Okay, so moving ahead, let's look at the left side here. How can I simplify 9 times n to the 6th? And that's underneath the square root. 9, if I were to take that and square root it, that's going to be equal to 3. And then my variable. That, because we're taking the square root, we're going to end up just dividing it by 2. So 3 times n to the 3rd power. Now let's focus on our 6 times n. We really can't do a whole lot with 6 times n. If I break 6 apart, the only way I can break it apart is into 3 and 2. Neither one of those are perfect squares. n does not have any other exponent. It's just n to the 1st. So I really can't break it down as well. So this problem is simplified as far as it can go. So it's going to just be radical 6n. So I have my final answer. Now I need to just put it together. So 3 n to the 3rd radical 6n. And that is my final answer. So again, the number side of it is really not changed. I'm still splitting it into 2 factors, one of them a perfect square. It's the variable, guys, that's new. I'm taking my number that is a perfect square, and I'm taking that variable minus 1 from it. So therefore, n to the 6th. And then whenever I do get rid of that radical, I'm just simply dividing it by 2. And that's because it works with squares, and it's our properties with exponents and square roots. Let's look ahead at number 4. This time I've got negative m times the square root of 80 times m to the 9th. Now, I want to focus real quick on this negative m that's out front. If you ever have anything that's out front of your problem, I'm going to recommend doing that last. Just leave it out there because that's really going to be the easiest part of this problem because it has nothing to do with this square root. So let's go ahead and let's focus on breaking this one apart. So 80, I want to break it apart into something that has a perfect square. Now, 8 and 10. Not great. Neither one of those are perfect squares. So let's kind of see, what else could I break 80 into? Well, if I divide 80 by 5, that's going to give me the square root of 16. And I know 16 is a perfect square. So the square root of 16 times the square root of 5. And there we go. I've got my 2 factors now. Now let's focus on my variables. So I'm going to have m to the 8th on the left, and I'm going to have just m on the right. From here, now we want to simplify, and don't forget about your negative m. If you don't carry it down, more than likely you're going to forget about it in your problem, so just keep bringing that one down. Let's simplify the left. So I've got that negative m I'm going to worry about here in a minute. So negative m times, now let's simplify this, radical 16. If I break that down, that equals 4. And now my variable, m, and remember, we're just dividing by 2. So it's going to be m to the 4th. And on the right, it's going to be times radical 5m. Can't do anything with radical 5. 5's a prime number, so that can't be broken down. M, it's to the 1st, so I can't do anything with it. So this is going to stay as radical 5m. All right, so we're almost there. The last part now is worrying about this negative m times 4m to the fourth. When I multiply, remember, these are our exponent rules. It's like m to the first times m to the fourth. When we multiply exponents, remember we're just adding them. So it's going to be 4m to the fifth. Now that first m was negative, so I'm going to include my negative symbol, and then that is times 5m. So your final answer on this one's going to be negative 4m to the fifth times radical 5m. And guys, I'm going to tell you right now, if you're not diligent with these, and if you're not really focusing on your work or paying attention to what you're doing, you're going to make mistakes with these. You've got to break them down fully into their perfect squares. And you really have to watch your variables. There's a lot of attention to detail on these problems. So I am kind of dragging this lesson out for a reason, just so you can kind of see all the different steps and details that we have to pay attention to. From number 4, I'm going to go to number 6 first, just because I like number 6 better than 5, and it's a little easier. Now let's look at multiplying, a new kind of step here in this lesson, multiplying radical expressions. So I've got 3 radical 6 times radical 18. So I want to go ahead and I want to multiply these together. I'm just going to multiply all the pieces. So I'm going to multiply all the numbers out front together. So 3 times, this would really be like multiplying it by a 1. So it's going to be 3. And then inside is going to be times 6 times 18. So there you have it. Underneath your radical, you're just multiplying what's out front together. And then you're multiplying what's inside the radicals together. So pretty easy anytime you're multiplying radical expressions. So let's simplify this. It's going to make 3 radical. Now I've got 6 times 18. That's going to make 108. And now this problem just became one that we were doing like number 1, 2, or even 3 and 4. I just want to simplify this now. This 3 that's out front, again, just like the m, we're going to save it for last. And we're going to do this step last. Focus on the 108. How can I break it apart? Well, it's going to turn into 3. And let's see, what two numbers, when multiplied together, make 108? And if we divide this one out, I would first start by dividing by your perfect squares, because those are the numbers that you're going to use. So if I divide 108 by 4, that's going to give me 27. So that does work. Let's see if we can get a little closer here. What about 108 divided by 9? That gives me 12. So that does actually get pretty close as well. I'm going to try 108 divided by 36. Okay, if I divide 108 by 36, that's going to give me 36 and 3. So I know that 36 times 3 is equal to 108. So I'm going to use these two numbers. Now let's go through and let's simplify. So let's go ahead and simplify radical 36. So that's going to turn into 3, and radical 36 turns into 6. So don't forget about that multiplication symbol in between. That's all this really is, guys. It's just 3 times that radical 36. So I'm just going to carry everything straight down times radical 3. Radical 3 cannot be simplified anymore. That's as low as it can go. So now let's finish this problem off. 3 times 6 is 18, and it's going to be 18 radical 3. And there you have it. There's your final answer, 18 radical 3. Let's look at number 5. Let's head back to that one. So this one I've got some variables involved. So this time I have 2 radical 7t times 3 radical 14t squared. And again, multiply what's out front first. So when I multiply what's out front, I get 6. And then inside, it's going to be 7 times 14. So 7 times 14 is 98. Don't forget about those variables. So when I multiply the variables together, again, your exponent rules, it's going to be t to the third. And that's because you add. 2 plus 1 is 3. Let's finish this one off. So 6 times what radical times another radical. So let's split 98 up. So if I do 98 divided by 4, that doesn't work. What about 98 divided by 9? That one doesn't work. 98 divided by 16. Let's try 98 divided by 49. So again, run through your perfect squares. Start dividing it by those. So notice, 98 divided by 4, that doesn't work. That's a decimal. 98 divided by 9, that doesn't work. That's a decimal. Run through them all. So I finally got to 49. So 49 and 2. So 98 can be split up into 49 and 2. Now let's work with that variable. So the variable, again, on the left, it's going to be t squared. And because we're just subtracting 1 from it. And then on the right, it's just going to be 2t. Let's go through and let's simplify. Now I'm going to have 6 times what? Well, when I simplify radical 49, that's going to be 7. And remember, we're just dividing by 2. So when I divide by 2, 2 divided by 2 is going to just be t to the first, so 7t. You could also look at it, guys. The way you cancel out a square symbol is with a square root. So those are going to cancel and just leave you with t. And that's going to be times, well, you can't do anything with 2t. 2 is as low as it can go, and t is to the first. So that's as far as you can go there. 6 times 7t is going to be equal to 42t, and then radical 2t. So all we've been doing, guys, is just been breaking this apart, simplifying the left and the right sides, and then just kind of putting them back together as your final answer. So your final answer on this one is going to be this 42t times radical 2t. There you go. All right, let's look at another example here. Number 7. We're not far from being finished, guys. I've got 10 problems total. We're on number 7, so we're getting there. Number 7. So this time I've got d squared equals w squared plus 3w, 3 times w, and then that quantity is squared. We need to simplify this first. So we don't really have it where we want it. So anytime they give you an equation, you're going to have to kind of move some pieces around. So let's go ahead and let's get this simplified as much as we can before we start solving for anything. So I know that I can square everything that's on the inside here. So d squared equals w squared plus, when I square, I'm going to get 9w squared. Well, hey, I can combine like terms here now. So d squared equals 10w squared. Now, from here, again, I'm trying to simplify this one down as much as I can. I want to find what d is equal to. Well, how can I get rid of this squared symbol? The way to get rid of the squared symbol is by taking the square root. So by taking the square root, d is going to be equal to, well, let's break this one apart. How can I break up 10w squared? This is one, guys, where actually I'm going to use 1, and that's because I can get rid of this w squared, but I can't really do anything with 10. So when I break this one apart, I'm going to break it apart into w squared times radical 10. We go through and we simplify. D is going to be equal to, this is going to turn into just w, and that's because the square and square root cancel out, times radical 10. Can't do anything with radical 10. It breaks into 5 and 2, not perfect squares there. So that's as far as we can go. So the final answer here is going to be w square root 10. W radical 10. All right, so there we go. So that's what d is equal to. D is equal to w radical 10. And maybe that's not a bad idea, guys, in your notes there. Put solve for d. So that's what we were doing on number 7. We were solving for d. All right, last couple problems. Now, before we get started with our last couple problems, we are introduced to a new rule, and this one is with division. On this set of rules here. We have when a is greater than or equal to 0. So a could still be 0. And this time b is greater than 0. So b cannot be 0 here. It has to be greater than. So when I take the square root of the fraction a divided by b, it's almost like I can apply that square root to the numerator and I can apply the square root to the denominator and then just solve. So my example here would be if I had 36 divided by 49 and I take the square root of it, I can apply that square root to the numerator and the denominator. So the square root of 36 is 6, the square root of 49 is 7. So my final answer would then be 6/7. So let's take that rule and let's kind of apply it to number 8 here. So my problem is 8x to the third over 50x, and that's all underneath this square root symbol. Now, something to look for in these problems before you begin is, can you simplify? I'm still looking for those perfect squares, and neither 8 nor 50 are perfect squares. But I can simplify this because they're both even numbers. So by simplifying this new problem now, I can divide them each by 2. It's going to turn into 4x cubed over 25x. And hey, that really kind of helped us out because both 4 and 25, they're both perfect squares. So from here, I can apply that rule and say the square root of 4x cubed over the square root of 25x. So that's my new problem that I'm working on solving. My next step from there is I want to go ahead and kind of separate this one out a little bit. Real quick, guys, before we begin, there is actually one more step you could do in simplifying this, and it has to do with your x's. So anytime, this was of those exponent rules, anytime we had division, so if I have x cubed up top and just x on the bottom x is going to cancel, and the top x turns into x squared. So that's through subtraction, okay? So let's go ahead and let's fix this in our final problem. So we've got 4x squared over 25, and both of those have the square root symbol going along with them. So whenever I go through to simplify, the square root of 25, that's going to be 5. So there's my denominator. And then on the top, the square root of 4 is going to be equal to 2. And then the square root of x squared. Square root and the squared symbol cancel. So it's just going to be 2x. And there's your final answer. 2x over 5. All right, you guys have almost made it. Number 9. Let's go ahead and let's get started. So this time we have the square root of radical 3 divided by the square root of radical 7. So anytime you have a problem that's proposed to you this way, where the square root symbol, we've already kind of made it like to this final step here. Anytime we're given a numerator and denominator where the square root is applied to both of them, that is when we need to get rid of the square root in the denominator to simplify. So in order to solve these problems, I'm going to multiply the numerator and denominator both by what the denominator is. So in this case, I have radical 7. I'm going to multiply the numerator by radical 7, and I'm also going to multiply the denominator by radical 7. And that's because I cannot have a radical in the denominator. You just can't. You cannot have a radical in the denominator. And the only way to get rid of this radical is to multiply it by itself. So if I take radical 7, now whenever we multiply, and I multiply this fraction through, whenever we multiply in this fashion, guys, they're actually going to cancel one another out. And this is how we get rid of. All right, let's backtrack real quick. So again, we're multiplying by the denominator, so we're multiplying by that radical 7. So let's go through and let's just go and multiply just like we would with two fractions. When we multiply with fractions, we can multiply straight across. So when I multiply straight across here, we're going to have radical 3 times radical 7. That turns into radical 21 over radical 7 times radical 7, radical 49. And this is just like problems 1, 2, 3, and 4 that we did on the first page. Now let's go through and let's simplify. So radical 49 on the denominator, that's a perfect square. So that's going to turn into just 7. And it's kind of a trick, guys, with these that I've always kind of learned. And this is where I wanted to say it earlier, and I kind of backtracked myself when I was saying they could cancel out. Whenever you're multiplying a radical by that same radical, the radicals, in a sense, kind of cancel each other out. And that's where we're left with just that whole number, okay? So again, I was kind of getting at it earlier, but I wanted to show you kind of why it made sense in a way. So my denominator is just 7. And now I'm left with radical 21. Well, you can't really divide radical 21 by anything that makes a perfect square. It's not divisible by 4. It's not divisible by 16. So that's really simplified as low as it can go. So radical 21 over 7 is going to be my final answer. And again, you cannot have a radical in the denominator. So that's why we had to kind of go through those extra steps. All right, number 10, last problem, all right? You made it. You've almost done it. So this time we've got radical 7 divided by radical 8. Let's go through and let's solve this one. So before I begin to kind of solve, and there's a couple ways you could do this, but before I begin to solve, again, I'm going to look for any opportunity I can to simplify before I begin this multiplication step. And I can actually simplify my denominator down. My denominator is 8n. I can break 8 apart into radical 4 times radical 2n. And then this will simplify because radical 4 is not going to stay like radical 4. It's going to turn into 2. So my new fraction that I'm working with is radical 7 divided by 2 radical 2n. If you go through the extra step here and you go through and simplify anywhere that you can before you begin this multiplication process, it's going to make it a lot easier to get to your final answer than it would be if I had just multiplied by whatever this denominator was. Let's go through and let's finish this problem. So again, I can't have a denominator, I cannot have a radical in the denominator. So we need to multiply both the top and the bottom by 2 radical 2n. Whenever we multiply and we go through and whenever we multiply, and let me change this real quick. Multiply by just the radical, because again, we're wanting to get rid of just the radical. Mr. Garrett's getting a little sleepy. He slipped an extra 2 in there. So I'm multiplying by just the radical. I want to clear any confusion there. So we're just going to multiply by the radical 2n. So whenever I multiply by just that radical 2n, now we go through and we multiply. So the top is going to turn into 14n, radical 14n. And then my denominator, that's going to turn into 2 times radical 4n squared. And that's because we're taking this radical 2n times radical 2n. So 2 times 2, 4, n times n squared. All right, now a couple things we have to do real quick before we finish this problem out. Now, my numerator, it's already finished. I can't go any further from 14. I cannot divide it by a perfect square and simplify this anymore. So 14n is as low as we can go. My numerator, or my denominator, however, 2 times. I can simplify it. Radical 4 is going to turn into 2. Radical and the square symbol cancel. So I'm left with just n. So my final answer on this one is going to turn into 14n over 4n. And there you have it. Radical 14n divided by 4n. So again, you're just multiplying by that radical. Guys, there was a lot of information with this lesson, and I really hope that every single one of you watched it. Again, I told you you're going to have a kind of a surprise problem at the end of this video. I want to give you some easy points in the grade book, and I want to just do this to make sure that everyone is watching the videos. And guys, if you're not, it's only going to hurt you next year for high school. Your problem that I'd like you to do, and I want you to send me an email with your answer, is going to be radical 2 over radical 3. Go through and solve it. Send me an email, give me your answer, and let me know what you get. Guys, I hope you enjoyed it. We're almost there, almost to summertime. Apologize for the lengthy video, but in all reality, this was still shorter than your class time you would have had at Westside Catholic. Guys, I miss seeing every one of you. If you have any questions, reach out. If you just want to talk, reach out. Let me know how you're doing. Hope everybody is doing fabulous and is ready for high school. Guys, have a good day.